The research we're doing at CUHK, I'm presenting part of it, is called Kit Parts Design for Architecture Co-Creation Games. So first, what is co-creation? Well, co-creation is a method that engages stakeholders and end users to cooperatively generate innovative design ideas. In an increasingly digitized design process, video game technologies can help to democratize design knowledge and bridge skills gaps. This study wants to do two things. First is to experiment with the design of building parts in a sandbox game to engage end users. And second is to try and understand the creativity generated in the process. But first, I wanted to talk a little bit about why we have to play. Well, actually, play is a participatory and experiential form of learning. Just like the previous presenter has tapped into, how can we actually help participants to better understand design information before we ask them to tell us what they want? It can help to drive creativity to enhance co-created design solutions, whereas creativity can be combinatorial, exploratory, and transformational. And this research looks specifically at the first one. Within a sandbox game, players combine ready-made pieces, we call it a kit of parts, to generate new creations. This can produce unfamiliar combination of familiar ideas, which is a form of combinatorial creativity. Just imagine we're putting A and B together and it becomes C, and we're going to do it so many times iteratively until we're all informed of the decisions that we make. And that's why we choose to do it in a virtual environment in a sandbox video games. Sandbox games are games without predetermined goals. It can allow a greater degree of freedom and creativity. So user co-generated game elements around for almost 2 decades. For instance, if any one of you have played Second Life, it's actually a virtual open world simulator. However, it was quite difficult to actually mold digital assets in Second Life. It required a lot of skills to 3D model and to customize its virtual objects. And that's why today games like Minecraft is so powerful because it's so accessible, it's so user-friendly. If a 5-year-old can do it, then theoretically, all of us can do it, right? Yeah, and you can see an example of Minecraft. For the project, we've looked specifically at architecture co-creation games, and these are some examples. They all have their own customized kit parts, which are basically object-oriented building technique where components are pre-designed or prefabricated. According to theorists, these sort of kit parts can be identified into 3 kinds. First is a modular integrated, which is largely applied in construction industry. Second is discrete, which is more applied in architecture theory. And third is modular, which has been here for over a century since Le Corbusier. But what do they imply within a virtual environment? Well, first, the in-between space from the stacking method can perform regularities or irregularities, and the part will simultaneously constrain and enable different spatial arrangements. And for instance, parts who are self-similar can be abstracted from a real-world understanding, but at the same time, it can allow a greater degree of freedom in activity scenario. Just like playing Legos, we can freely arrange the composition. And finally, with respect to granularity of the parts, if there are too many of them to choose from, it can be very overwhelming for participants. Too little can restrict technical possibility. Just imagine an IKEA catalog. If there are too many elements, you lose your orientation. So in summary, we wanted to look at the relationship between kit parts design and combinatorial creativity with the following qualities: the stacking method, self-similarity, granularity, spatial arrangement, activity scenario, and technical possibilities. And of course, we have a research question. How are technical possibilities, spatial arrangement, and activity scenario affected by the parts design? We have a 4-step participatory action research method. Every step, it tries to involve local residents in the process. First, we want to understand actually what are their preferences of community activity. And then we're going to integrate that into a spectrum of KOP design. And finally, we're going to test these KOP systems with the residents, and then we're going to understand the combinatorial creativity that was generated in the process. For objective 1, these were the collected data analyzed. We understand that, well, they want a lot of greenery, they want to exercise, shop and commerce, playground, and a lot of free space. And as you can see on the left, that actually goes correlated with their daily activities. And so the question we ask is, how can we unleash creativity beyond what they already have and what they're already doing? Well, second is the integrated spectrum. As you can see, modular integrated, the modules would be like a square cube. And the benefit is that you can easily arrange them in a space without too much complication. And all the way to discrete, when the granularities are really small, the time that is needed to play around with the parts will be increased. And accordingly, 3 kit-apart systems were designed, and they have very different qualities. The system 3, which is a discrete part, only takes 18 components to generate a myriad of possibilities. For the other ones, because they are functionally architectural, which means that you need different components for different function, and that can add up to 60 or sometimes 100 parts before you are able to build something meaningful. The process was also very simple. We first start with the physical tools, like participants will work in groups to write on worksheets, and then they will go into the sandbox game to arrange the elements, and finally they'll review the design in VR. Now let me just show you some preliminary results. This is by far, when I saw this result, it was the most devastating, but actually the most interesting one. If you look carefully, well, we did this in Hong Kong, and this is actually very Hong Kong. What participants found out was that each modular integrated component is 5% of land area. So all they want to do is fit what they wanted within the 100% of space. And despite the design initial coherence, they realized, oh, actually it does not fulfill what I wanted. So then in second round, everyone tried to lobby each other with very minor changes in the end, because they're afraid that if they change anything, their opponent will make something even more surprising for them. So I think this basically simulates a managerial decision making within high density environments where everyone's just fear of making mistakes because of the limited resources. So the next round, we tried to unleash their creativity using the modular components, and you can see there are a bit more sensitivity within density and orientation of parts because the modules are no longer integrated. And so they can liberatingly discuss what kind of activities they want within the space, and that led to different activity scenarios. However, the decisions are a bit arbitrary, as you can see. And so with the discrete system, we had to start with a bit more formal guidance because everyone was lost. It turns out not everyone is very good with Lego, especially adults. When you give them parts that are all similar, they're just scared to actually make things. And so we had to give them a guiding book for them to practice with small exercise. But actually, that gave some limitation, although it gave them freedom, which is that the formal guidance actually helped participants to exhibit repetitive visual similarities because they were following instructions. So sometimes it was also difficult for them to think outside the possibilities. And so this is the final game where we mixed in the modular and the discrete. Well, it was very interesting because without any formal guidance, they started to use the discrete part to set apart different areas, which is kind of like a figure ground exercise that architects would do. And then they realized, oh, all of the areas look very similar. So they used the modular part to give more meaning, architectural meaning to the space. And that gave a variation of spatial quality. And finally, as they were discussing, they realized a lot of things that they wanted actually not in a kit. And the kit already had around 150 components. And so the designers had to 3D model everything on the spot. And that was a bit of a chaotic situation. And so the next step, we will learn from the lessons and try to understand how we can also leverage open source technology to maybe help tackle the situation. So finally, I would just like to answer the questions that we posed at the first, which is that the level of granularity actually affects technical possibility by the level of design details, participation effort, and customization options. And also different stacking methods will affect the spatial arrangement, of course, figure-ground relationship, and the parts orientation. And finally, parts that are self-similar, it's easy to identify patterns and assemble a complex activity scenario design. However, the absence of pre-designed function can encourage creativity, experimentation, and a sense of discovery. It actually encouraged participants to explore different combination of spaces. And finally, the big question, do we go for modular or go for discrete? Well, actually, they're all good for different things, and it depends on what kind of co-design you wanted to achieve. For modular integrated system, it's actually good for simulation. If you want to simulate how people make decisions, then I highly encourage you to use that. For modular system, it actually requires architectural understanding. You have to understand what a stair means, what a door mean, what does it mean to put a chair in some places and put a corridor in other places. And that means that participant needs a learning opportunity and maybe even some active learning education before we actually use the parts. For this grid system, it's really good at fostering creativity, but it will also need a mini design exercise to help participants understand how to form open space and closed space by arranging the elements. And however, all of these systems require careful consideration to avoid generic outcomes and maintain a balance between guided variety and design abstraction. And finally, if we mix a system, it does allow greater flexibility, but the limitation is that everyone is overwhelmed based on the options. And also, even with a lot of options, that doesn't mean everyone's needs are actually encoded within this kit parts design. So finally, this is an image where we post-processed the outcome to visualize how the scenario will look in the public space, which is in a high-density housing estate. Welcome to get in touch and collaborate. I'm sure to try and apply the same methods in different contexts, we will get different results, and I think that's the most exciting part. Thank you.
Okay,